So let's go ahead and talk about substitution. When we are using the substitution method for finding the solution for our systems of equations, the definition for substitution method would be a method of solving systems of equations by subtracting equations. Oh, not subtracting, I'm sorry, substituting equations within one another. Sounds like a slightly confusing definition, but I promise you it's a lot easier than it sounds. Step one would be to solve an equation for either x or y. When you do that, you will substitute that equation or the expression in and then solve for the other variable. And then again, step three, we're going to take that answer, substitute, and solve again. Let's go ahead and talk about some examples. The first one, notice both of these are already solved for y. So over here, one way that I could do step one is to solve both equations. Oops, that's not how you spell both. For the same variable. When we do that, we can actually just set them equal to each other. Since both of these equal y, then technically they will equal each other. And now we can find x. So the first thing we want to do is move our x's together. So I'm going to subtract 2 from both sides. And I would end up with 2x minus 1 equals -5. Then I'm going to add 1 on both sides. And when I do that, I get 2x equals -4. And now we just divide by 2 on both sides. And we end up with x equals -2. So the same thing when we did graphing, we are going to want an x and a y value. So now I'm going to take this x value and plug it back into one of the two equations we have. So now I want to put x in one of those two spots. It won't matter which one you choose. They both should equal the same number unless you did some poor math, you messed up once. I'm going to choose the top one just because it's on top. So we would have y equals 4 times a number minus 1. And my number is -2. 4 times -2 gives me -8. And -8 minus 1 gives me -9. So the solution for this one will be at -2, comma, -9. The second way we can solve these, notice this says y equals, and I have a y spot. So I'm going to take my y equals and plug it in. So we would have 2x plus 3 times something equals -20. For this one, we said y is 6x, so we'll plug that in. And we end up with 2x. 3 times 6 gives me 18x, which is -20, which means I have 20x equals -20. So my x will be -1. Now for this one, I think it does matter where we plug in our x value. Notice one of them is going to be a lot easier to solve. One of them has a lot more steps, and when I say one of them, I'm talking about this one right here. Notice it is longer. Also, we have multiplication next to both variables, so it's not going to be an easy feat. So I will choose the first one, y equals 6, and then we're going to plug in our x value, which is -1. And all we have to do is multiply and we get -6. That one was really easy. I will show you as well what would have happened if you chose the second one, so we can just compare a little bit. We would have 2x plus 3y equals -20. And we plugged in -1. 2 times -1 is going to give us -2 plus 3y equals -20. We're then going to move our 2 with addition. So we would have 3y equals -18. And then we have to divide, so y equals -6. So we still do get there in the end, but one of the ways was a lot easier. Let's go ahead and do one that's going to be a little bit more difficult. We'll go down here. Notice neither of them are solved for x or y. So what we need to do is pick one and solve it. The first thing that I'm going to look for is a y or an x that does not have a variable out front. So I'm going to solve this one. Variable, I'm sorry, doesn't have a coefficient out front. So I'm going to come over here off to the side and rewrite this problem. And I want it to say y equals or x equals. In this case, I'm going to choose y because it's all by itself, which means it's going to be a lot easier to move. Minus 2x on each side. So that cancels. And I am left with y equals -2x plus 9. Now, when we do this, you cannot plug this back into the original formula that we just changed. It would be kind of pointless to say 2x plus -2x plus 9 equals 9. That's not going to work. We can't use that formula again, so we have to plug back in to this y. So we will end up with 2x minus 3 times -2x plus 9. And then we can carry the rest of it down, so equals -11. We need to distribute that -3. -3 times -2 is going to give us positive 6x. And -3 times 9 is going to give us -27. We can combine our x's together. We'll end up with 8x. And we can also move that 27 with addition. We'll end up with 16. So 8x equals 16. When we divide by 2, or by 8, we get that x equals 2. Now we can plug this back into 3 different locations now. So we can take that x equals 2 and put it into the first equation. We could put it into the second equation, or we could put it into the one that we created. I typically go for the first 2 equations, not the created one, because if I messed up my created one, then I'm really screwed. But we can do any 3, and I'll show you that as well. So let's start with the second one. The second one's going to be a lot easier, again, because x or y is by itself, so we would have 2 times 2 plus y equals 9, which means we have 4 plus y equals 9, and a lot of us can fill in the blank from there. Y will equal 5. If I wanted to plug into the first equation, we would have done 2 times 2 minus 3y equals -11, which means 4 minus 3y equals -11, which then becomes -3y equals -15. And when we divide, we still get y equals 5. And if we were to plug into this equation that we created, we would have y equals -2 times 2 plus 9, which means we get negative 4 plus 9, which is the same thing as 4 minus 9, which is still 5. So we can use any three of those ways. And that would be how we graph with substitution. I'm sorry, how we solve with substitution. Why graphing? Oh, whatever. You know what I mean.